Hi, this is a video explanation for the lab assignment 1. So, this is the first task which was given to us to convert the given tuples of different students and different marks for the given subject, and then we need to get the output as given in the lesson plan like this. So, this would be our output, which has a dictionary and sorted output of subjects with highest marks coming at the last. So let's start the explanation. So we have initialized tup, the list of tuples, and then we have called tuple to dict uh, met, method, and then this converts the given tuple into a dictionary in variable dict, which is initialized here. And then for a given idx, here means index, and comma list of tuples in data.items, we sort the values of the given list of tuples as based on marks. So when we execute this, we get John as a key, and the list of subjects which contains tuples of a subject and marks. So here 80 is lesser value than 95, so we get the output in this way. And next, this is the task 2, where we convert the given input and find the longest substring without repetition. So we are importing re module for this. String input equal to input, where we give the input of this input to the string input, and then we have initialized two empty lists, current and strings. So for let's go with the this flow. So for character in a string input, so what this iterations does is, so it makes the strings a list with a list of all the non-repeating non-repeating strings. So the string after this iteration would be pw, wke, and kew at 0, 1, and 2 indices respectively. So and then we are finding the maximum length from the given from the string list, and then we are using this length integer. So this substring contains only the strings whose length is 3. So we are here in this case the maximum length is 3, so we are omitting all the other values whose length is less than maximum value, and then we are replacing the square braces from the substring so that we can get the output in the desired way. Next, this is the user management system. So here we have created a flight class and a person class. Here we have created a constructor which has flight number from to date as different arguments passed, and then we have created two methods, get flight details and get flight count. Here is a class of person. So he has his constructor has three attributes: name, age, and sex, and then these values are stored into the object using self when object is instantiated. And then here we have initialized two methods: a print person details and get person count, which can be retrieved once the object is instantiated. And then we have created a class employee which inherits the person properties. So we have in its constructor we have called the super, which calls a which calls a constructor of person basically. And then so the extra argument employee id is saved into the object.employee id, and we are incrementing the count. To understand how many times how many times this the class has person and or employee has been called. So here we are creating two different methods: print employee details and print employee count. So here is a passenger class similarly with which inherits person and has extra attributes id, number, and flight, and we are assigning it to the object.id and flight details, and then we are also incrementing the passenger count similarly. So here we have two methods: print passenger details and get passenger details, which gives out the passenger. So this is a class pilot which inherits both the classes super say person and flight. So we are initializing pilot count to 0 and then incrementing whenever this class is called. So here is a constructor which has different arguments: name, age, sex, pilot, id and flight. So we are calling the constructor of person class, and then we are giving passing three arguments which the person constructor takes, and then we are assigning the assigned flight to uh, the flight dot get flight details from the flight class, and we are getting the output from the method get flight details, and then we are assigning pilot id from this argument to the pilot id and incrementing the pilot count. So we have initialized two methods, pilot details and get pilot count. So if name equal to main, so we are in the main function right now, so the this is true, and then the following statements are executed. The person 1 equal to person of Charan 23 and male. So the person object is instantiated with name, age and sex, and then two flight objects are instantiated with the five arguments which we have given previously. So we are initializing different kinds of objects for different classes. uh, Here the class pilot and the passenger both inherit the parent classes, so we have used them, and then we are trying to get the methods of different classes. So employee gets the print employee details and print employee details method from the class employee. So here we get the print employee details, and then for example let's consider the pilot class. So pilot can get pilot details and get pilot count methods which are here, and then so passenger 1 dot get person count. So passenger 1 gets the passenger count from the uh, passenger count variable. So in this way we can retrieve various methods and inherit the different classes. So here is this is the desired output. These are the first three tasks. Thank you. So next we go into machine learning tasks. So here is the fourth task where we need to use multiple regression by choosing our own data set and evaluate a model using root mean square error and R2 attribute. So here we are importing various libraries: Seaborn, NumPy, Pandas, Matplotlib, so to plot, and then we are reading CSV using Pandas library PD, and then data sample of list of the five of the rows from the given data, and then if there is any null, we want to sum them and sort the values, but there isn't any null. So if there is any missing data which is stored into missing, and then a percent is equal to, if there are any nulls we are summing them and dividing by if there is any null, and we are counting the number of nulls instead of summing. So count is different from sum, where count is just counts the number of nulls. So we are including np.object from numpy to understand the categorical data, and when we give sample of this, let's change it to 5. So we are getting different categorical data column. So here the state is the only categorical data column which has different categories. So we are plotting the histogram with profit on the x-axis and frequency on the y-axis. So here we can see that the profit of uh, 1 lakh rupees is more frequent than others. So we are trying to normalize using np.log, and we are normalizing the profit, and then we are getting the figure. We are drawing a histogram with profit on the x-axis and frequency on the y-axis. So when we have normalized, the normalized output of 11.5 has a maximum frequency, and then we are using a box plot to understand the outliers and as such to get more insights into the data. So we are drawing a profit versus state diagram. The states is on the x-axis and the profit is on the y-axis. So we are giving the data and we are plotting it. Here the California state, for suppose, has the values ranging from concentrating in the ranges of 75,000 plus and below 1,50,000. So in New York has some outliers which are shown by these points. So we can this is a plot which specifically draws on the price and the profit. So here the outlier is shown. So we are trying to remove the outlier using we are getting the columns which have profit less than 20,000, and then we are dropping them by getting the index of it. So we have the columns which doesn't have the profit less than 20,000, as you can see. And then we are counting the values. So new from the data of state which has 17 New York City houses and 17 from California and 16 from Florida as such. And then we are choosing all the rows here and the columns except the uh, last two, and then we are choosing the fourth column and converting it to values. So this is our data set. So 0, 1, 2, 3 and fourth column is a state, so that one we are using it to convert into y. So we are getting the shape which has 50 columns and 50 rows and 3 columns, and then we are choosing all the rows and column from 1 to the remaining. So we are using a pair plot here. What pair plot does is it plots between itself and various other columns. So here as you can see, the R&D spent is plotted with R&D spent itself. So the plot is a closed graph, and then remaining has of data points. So which so as you can see, the second one is administration. So as the administration price increases uh, is average, then the more number of R&D spent free data points are available here. So we need to spend, it shows that average amount is spent on R&D and average amount is for all the other graphs. We have drawn a pair plot. So then we are trying to use a linear regressor. So we are using train test split to read the values into x and y, and then we are giving the test as 0.3. We are using linear regressor and we are fitting the x train and y train into the regressor, and we are predicting from the test of x test. So we are getting the result into y prediction, and then we are finding the root mean square error using np dot square root mean square error y test and predict. So we are comparing the predicted output and the test output, and then finding the error. R2 is more normalized error which can be found from R2 underscore score of y test and y predict. So we have plotting a scatter plot between test and prediction. So if y equal to, if it lies, most of the points lies on y equal to mx, then the error is very minimal. So we are finding the distance of different data points from y equal to mx and understanding the error. And then so we are using one hot encoding technique here. One hot encoding technique makes the class attributes into a one hot bit and remaining as cold bits. Here from sklearn we are importing label encoder and one hot encoder. Label encoder converts the categorical data into the value. So this is the values we get for one column, and then we are using one hot encoder and we are giving the number of features as 3. So since we have California, Florida and New York as the categorical feature in the column state, so we are fitting the one hot encoder to array and printing the array. This is only just the one column which with one hot bit, so remaining hot bits for the corresponding columns. And then we are again test splitting, and then we are trying to find the again we are using linear regression and applying the regressor and predicting the output. Here we have used the same root mean square error and R2 score to find the errors. So here we can see that the error has significantly toned down. Here it is 6246.57, and then the previously it was around 31,000. So we have found an improvement by using one-hot encoding technique and label encoders for categorical data. Our next task 5, which is 5, is about using different classification algorithms, naive Bayes, SVM, and KNN, which were discussed in the classes, and we have to handle null values and removing the features which are not non-correlated. So let's start with the code part. So we have imported various libraries, and then we are reading the CSV file car evaluation.csv, which is this. So it is a column, a row for each car, and which gives different attributes. So here we are finding the head, which represents the top 5 rows, and then if we are finding the null and summing them, there aren't any nulls here. So we are importing C1 as SNS and printing total number of cars here, which is number of rows. So string of length of car data set gives the number of rows 1728, which is our data set of different cars, and then we are using count plot to get the so here we have used different categorical data. So here unaccounted, accounted, very good, and good are different values in the last column of the car data, and then we are plotting it with the count. So it counts the number of unaccounted, accounted, very good, and good data. And then this is also a count plot. So here we are using another attribute called safety. So for safety low, medium, high, it plots the count for in unaccounted, accounted, very good, and good. So here we are using hue as buying, and so it plots correspondingly. So if there is in null, we are checking the data for nulls. So in this way, and then we are getting the card data set of overall score and dropping the overall score so that we can separate the target data set and the required data set, and then we are plotting the histogram like this. Here we are trying to use the various algorithms as mentioned in our lesson plan. So since we have split the data into card dataset and the target, we are using these two for test train split, and then we are using standard scalar to scale the data, and we are using SVC and linear kernel for that, and we are fitting the data X train, STD, and Y train, which we are fed into here after scaling down and transforming, and then we are predicting the data using svc.predict of x of test. It predicts the value of y, and if both match, then we get a good accuracy score. So here we find the accuracy score from scalar metrics, and then we are finding the accuracy score. Here we got 70% as our accuracy score, and we are using KNN algorithm for the same data. So we are fitting the X train and T train data, and then XNN is a classifier algorithm, so it classifies the values into different uh, clusters, and then so I'm sorry, not clusters. It predicts the values based on X test, and then it finds the accuracy score from by comparing Y test and the predicted output, and then we are finding the accuracy. Here 90.75 is shown as accuracy rate, and which is very good. So for this data set, I think KNN is the best. Here it is a naive Bayes algorithm, which assumes that all the columns are uncorrelated, so they are mutually exclusive, and predicts based on the Bayes theorem. So here we are using Gaussian naive Bayes algorithm, and then we are fitting the data of X train and Y train, and in the prediction we are predicting using X test and finding the accuracy score by comparing the prediction and the test score. The accuracy score here is 78%. Maybe we have lost 10% due to many of the assumptions in naive Bayes. So our sixth task is applying K-means algorithm, which is a clustering algorithm. So we have to apply different EDM methods, and then we have to find what is the best K based on with the help of elbow method. So here we are importing various libraries. This is our code part. And then we are reading the file using pd.readcsv of wine.csv. So we are sampling the data. So these are the various columns, and these are the various values. So this is alcoholic percentage, and then the different chemicals used here. uh, so here we are just clustering the data. uh, so So we just describing the data, which is count, median, on all other attributes. If we are finding if there are any nulls, and is any gives the boolean, so all are false. For I in data dot columns, we are plotting the figure for different columns versus we are getting the frequency. As it is a histogram, only one column value is taken and the frequency is plotted on the y-axis. So for alcohol, malic acid, so alcohol has a highest frequency of 12.5%, around 12.5%, between 12 and 12.5%. So similarly for all the other graphs. And then we are dropping the customer segment because it is irrelevant for our data set. And then we are using the subplot figure size of 8 by 8, and then we are drawing a heat map using correspondent matrix. And here are the various column names which are plotted against the same column name. So we get highest correlation for if both the columns are same. So this is a different scale, and here is a heat map. So black says they are more uncorrelated. So here we are using pre-processing and standard scalar of that, and we are fitting the data, and we are transforming the data into the scaled array, and the x underscore scale is a data frame from the scaled array, which is a which can be manipulated further. So k means is we are giving a cluster of 2 and fitting the scaled data. So we are getting the centers of 2 list of lists. So in range 2,11, we are fitting the scale data, and we are predicting the cluster in cluster and we are WCSS append k-means dot inertia gives the squared distance from the centroid in a cluster, and then we are scatter plotting the data. So between different between 0th column and the first column. So here is a scatter plot, and there is a chill out score zeros which ranges from -1 to 1. So 1 corresponds to more better chill out score, and then this is our elbow chord, which is 3 is the